Okay, we're gonna get started right now on page 29. I'm pretty sure your class, we already got through page 29, right?
Yeah.
So just a review of what you need to know for the regions at this point. So this was all the notes from page, well, it was all the universe notes from page 29. But just again, what do you need to know about the universe for the regions? One, you absolutely must know that the universe is everything. It's the biggest thing that we could talk about is the universe. The solar system is part of the galaxy, the Milky Way galaxy. The Milky Way galaxy is part of the universe. Yeah.
So is the universe the biggest thing we'll talk about in this class?
Ever, worlds, like it's not even the biggest thing in the world because it's bigger than the world. Yeah. So here's the problem you guys have with this concept, which is one of the things that will literally give my own daughters like panic attacks trying to figure this out. So what Izzy was just asking is, so if the universe is everything, how's it expanding? Right? Like, where's it going if the universe is everything? Yeah, I don't know. A lot of people go with also the Big Bang Theory. How could an explosion happen if there was nothing there to explode? And how can an explosion make the world and the whole universe? Yeah, I don't know. Nobody knows. So
Technically, the sample wasn't.
okay, true. So where I'm going with this is the Big Bang Theory and this concept of space and this concept of the universe even is a highly studied topic by people much smarter and more educated than myself. And they still don't know. Like Stephen Hawking is the perfect example. Now, yes, he has died, but he was a very smart scientist who did nothing but educate himself for his entire, I mean, he did stuff, but he was constantly learning and researching this, and he still couldn't explain it. The scientists, yes, they're just TV characters, but Sheldon on the Big Bang Theory, this was what his research was on, and they still could not explain it. Yes, they ended up getting a Nobel Peace Prize because they got a little closer to understanding it, but they don't understand it enough for the rest of us to understand it. So then why do you have to know it? Because they do know a few things. They know that the universe is the biggest thing. They know that there was this Big Bang. How do they know there was a Big Bang? Because we have proof the universe is still expanding, and that proof is called the red shift. Now, we talked about that in this class, right? We got to this next page. Right, we did this? Okay, so again, just to review what you see here, because I did have a lot of people absent yesterday, maybe not so many in this class, but spectral lines, we looked in the spectroscope, right? Did you guys look in this thing? Yeah, you looked in this thing, and what you should have all saw was the rainbow huddled in the middle-ish. Like I said yesterday, if you look to something that's moving away, the rainbow is squished over to the red side. If you look at something that's coming towards you, that rainbow is squished to the blue side. Hence the red shift. We shine one of those spectroscopes out into space, and they see that those galaxies are squished over to the red side, which proves they're still going away. I told you that I remember this because a car driving away from you, what lights do you see? Red taillights. So that's all you need to know about this concept is that the Big Bang happened. It created the universe and everything in it. The universe is still, the proof for that is the universe is still expanding, and we know that because of the red shift. Red shift, red taillights, driving away. Blue shift, blue headlights, driving towards you. That sums up yesterday and the facts that you need to know. And you don't need to know more because more, we're not even sure. So stick with just what you need to know for this. All right, now, are you ready for the last thing you're going to learn this year? Okay, good. All right, what?
What's your opinion on stealing?
On stealing?
Hello.
Don't do it.
There, stole from me.
I'm sorry, take it up with the office. Let's get going here. We got the life cycle. What do you? Is it something we need to take care of now? Do you guys
No.
need to leave and go to the office and take care of it?
I'm all
Oh,
right.
no, you skipped it right there, right in that page.
I don't have, I don't have it. We grabbed it all the way back.
It is part of the Earth system science, yes. It is. So stars have a life cycle. Just like you have a life cycle. You started off as a baby, then you turn into a kid and a teenager and an adult who has to make full-blown decisions with their lives coming up soon. That's basically what a star does too. So if you guys could fill in a nebula is where stars are basically born. It's like a nursery. So a nebula is a cloud of dust, hydrogen, and plasma. And stars are born in a nebula. Once they're born, they turn into this thing called a protostar. Have you ever heard of a prototype? So they make like a prototype of a car before they start mass producing it. They make a prototype, so kind of like a model or an example. And that prototype isn't exactly what ends up getting manufactured. Sometimes they spice it up a little bit and make it a luxury car. Sometimes they dumb it down and make it a cheap one that everybody can afford. So a prototype isn't the exact copy of what's going to be made. And the same thing with a protostar. So it kind of almost reminds me of a teenager where you are getting molded right now. You're getting influenced by outside decisions or outside influences. Right now, you're trying to decide what you want to do with the rest of your life. Good luck with that, by the way. So that's what you're working on right now. You're developing. That's what happens in a protostar. They're developing. Once you graduate, you have some decisions to make. So after the protostar, the star has two possible paths it could take. It can either turn into a massive star. So I like to compare this to like a luxury car. So it's going to turn into a massive star that turns into a supergiant supernova explosion that could turn into a black hole or a neutron star. Sounds all exciting. Or it can become like an average everyday car, which is called the main sequence stars. They do go through a life cycle and they go through being a red giant and turn into a planetary nebula or a white dwarf. You have to memorize this? Absolutely not. What you need to know is they are born, they spend some time as protostars, and then they have two choices to make. That's all you need to know. Know that this exists, but you don't need to memorize main sequence goes to red giant and all of that stuff. Just know they're born, spend some time, and then have two paths to take. That's all you need to know. What you got, Blaze? What are you looking at? Okay. So that's all you need to know about the life cycle. So still not doing much with stars. Now, you guys know there's lots of stars out there, right? Like billions and billions and billions of stars in the sky. So how come, how many stars are in our solar system? One. How come that star looks so much bigger and brighter than all the other stars? Okay, you guys all know that? That our sun is bigger and brighter because it's closer? I figured. Okay, good. So for the rest of the stars, they're all different. In fact, our sun is actually just average. Even though it's big and beautiful and bright and like required for us to live, it's just an average old everyday star. So on the top of the next page, oh, I lied. One more thing first. I'm sorry. Down there at the bottom, cross off star formation for me, would you? This is a fact about stars you just got to know. All stars are basically nuclear power plants. And that is how a star gets its brightness and its energy and its heat. So our sun's no different. Our sun is up there doing nuclear fusion.
Pretty cool.
It is pretty cool. Nuclear fusion, the word fusion, like fusing together, means you take two atoms and you fuse them together to create one atom. So on our sun, we are taking two hydrogen atoms, putting them together and making helium. We cannot do this as humans. We can do nuclear fission. So fission if you know what it means, like a fissure means to break apart. So we can take an atom and split it apart into two other atoms, also creates energy, but a lot less than fusion. Yeah,
So like, is the sun just a ball of gas? So
Yeah.
like, if you weren't gonna get burned, could you like go through it?
yeah, I think, but I'm not sure.
I'm back left.
Do you need to go?
Oh, no, my phone's still in Google, but I'd stay after school.
Oh,
at
okay.
least you have your phone.
All right, anyway,
We
you
can-
have to remember that the sun is doing nuclear fusion. And you can't accidentally say it's doing nuclear fission. Are you ready for the final really goofy way I remember things? I got, this one's gonna top the cake too. I saved the best for last. Some of you are actually gonna just not even get it.
Remember what?
That nuclear fusion, not fission, is happening on the sun. You ready for it? F you, son.
That's enough.
Okay? F you, son. Not the bad words, F you. Please don't think that's what I'm saying. F you for fusion instead of F-I for fission. Okay? So you do have to remember F you, son. Can you do that? Okay, so that stands for nuclear fusion on the sun. F you, sun. Fusion, sun. Please remember it. I have no more. That was the last really weird way I remember things. Well, will you remember them?
Nope.
F you, sun.
Wait, you should. Hydraulic.
High, dry, cool and clear.
Cool.
You gotta sound a little high when you say high, dry, cool and
I
clear.
don't think you know what
Told you, my teacher died of a drug overdose. All right. All right, moving on to stars. Stars are not all the same, even though, yes,
After this, call these people and ask her if I have my 12-3 freak, I come down there.
I am not calling and interrupting Mrs. Zupo's class.
She's in the class right now. It's 10, 11, 12, or stay after. My phone's in the room, I can't chat her.
Hey.
Wait, Miss Ritz,
Hey.
do you want me to run down real quick?
No, right now, let's finish
What
this.
if you do like a relay?
Yeah, we should do a
We're
relay.
good, guys, let's finish this up. Stars, they all look the same in the sky from where we are, but they're not the same. They are different. They have different masses, weights, size, temperature, and brightness. Our sun is just average, and it's what's called located on the main sequence. We're almost done.
Do I need a predetermined, path to go down there?
I have no idea.
That's starting next week. Wait,
I don't
should
understand
be
the new rules.
I feel like slow.
Let's just finish this and then we can complain after.
I like that idea.
Okay, I'm recording, so everybody be quiet. I'll tell you what the main sequence means in just a minute. It just means average, but I'll show you. So scientists love to group things. Scientists need to put everything into groups. What's it called, putting things into groups? Classifying. So scientists have classified the stars, and that is not random. Stars are classified based on their temperature and brightness. You can actually skip that second bullet. It's not important right now. I'll show it to you what it means in 1 second. So stars get grouped based on how hot and how bright they are. And the person who did this, their name is Henry Russell. And I don't know how to say his first name, but Hertzsprung and Henry Russell are the guys who did the classifying of stars. They don't make you memorize that. It's called the HR diagram. And the HR diagram compares the spectral class, which just means color and temperature, of stars against their luminosity, which means brightness. Because of course we have to use fancy words for the word brightness. Luminosity to me sounds like illuminate, which means to make bright, to shine a light on something. And you have an HR diagram in your reference table. Can you guys go ahead and grab your HR diagram in your reference table? Hint, it's the last reference table that we have not talked about yet. Was yours stolen?
No, I feel like we're gonna have to.
Oh,
Because I know.
That's the difference between taxi and pay.
here is the HR diagram. You can see at the top, it's talking about the characteristics of stars. What we have going on here, often people think this looks like a map of the sky. So like if you look up, this might be what you see. That is not what this is. This is basically, I mean, it is just a graph, not even basically a graph. It's just a graph. A graph with an X and a graph with a Y axis. The X is a little weird. Normally, X-axis starts at the lowest and gets higher. Please pay attention, maybe even circle these. This graph starts with the hottest on the left. And then it gets colder as you go over to the right. So this goes from the hottest to the coldest, which is not how you're supposed to make a graph, but the Regents doesn't apparently need to follow the rules. So temperature in Kelvin, so these aren't Fahrenheit or Celsius, it's Kelvin, is on the X, and so is color. So color and temperature, they actually go hand in hand. If you've ever noticed, there's different color flames. Like when you burn wood, you usually have a red or an orange flame. But propane or natural gas, you're gonna have the white or blue. And I'm not sure if you know this, but propane and natural gas fires are hotter than wood fires. So it does make sense. It does go in order. So we've got temperature and color on the X. We've got luminosity, which again, if you don't remember, means brightness. Now it does say these are, what did it exactly say? They're relative to the sun, meaning here's the sun, it's labeled right there. The sun has a brightness of 1. So the sun is equivalent to 1 sun, which makes sense. As you go up, this one here is 10 times brighter than our sun, 100 times brighter than our sun, 1,000 times brighter than our sun. I think you get the point.
Pretty bright.
Very bright. It gets up to 1,000,000 times brighter than our sun. Going down from 1.1 means it's 10 times less bright, 100 times less bright, 1,000 times, 10,000 times less bright than our sun. So this is a graph they've plotted. I don't even know how many stars there are. So every dot counts as a star. But you can see they obviously only labeled a handful of them. So they won't ever ask you about like this random star right here. They'll only ask you about ones they've labeled. So keep that in mind. So it's just a graph. Temperature, brightness, you'll get to a star. You might notice that it kind of looks like there's like groups of stars. So I'm hoping you see that there is a group right here. There is a group right here. There's a cluster here and another cluster here. These are the different types of stars. If you remember, these are the stars that were named on that, with the life cycle part. So we've got white dwarfs, supergiants, giants, and then the main sequence. So I did mention in the notes that the sun is on the main sequence. You can see it's in this cluster here. And these are stars that behave like you expect. It's almost like you know how Main Street is considered like, not necessarily just here, but anywhere. It's always like the center of the village. It's like the average person lives on Main Street or whatever. It's not necessarily true. It's just kind of the way it is, I guess. Stereotype maybe. But anyway, that's what this is. This is the average group. They behave the way you expect. What I mean by that is, if a star was hot, would you expect it to be bright or dull?
Right.
Yeah, so these guys, they're hot and they're bright. They're cold and they're dull. They behave the way you expect. Now these supergiants, I would think something called a supergiant would be like big, bright, and probably hot. It's not. It is big. It's up here. Oh, I did forget to show you this. Also on the y-axis is the size. So small stars are down at the bottom, big stars are up at the top. So this supergiant, it's huge. It is very bright, but it's on the cold side. It's only around like 5,000 degrees or 5,000 Kelvin. Same with the giants. I'd expect something that was huge like a giant to be really hot, but it's actually some of the coldest stars. Now, white dwarfs, something that was small, I would think would be kind of cold, but if you notice, it's on the hot end. It's one of the brightest stars you're gonna find. So they don't behave, so they made their own group for them. It's just a graph. X, Y, yes, there's groups. It's not complicated. Do you think you could answer questions about it? I see some of you already are. There's 8 questions right there below where we just took notes. Can you take a moment to do, actually, don't bother doing question 6. They used to group a red dwarf group too, but they got rid of it off the Earth Science reference table.
The small one.
Yeah, there are small ones that are red, so yes, those would be them, but they uncomplicated the reference table for once. So go ahead, do these 8 questions. I'm sure it'll only take you a moment. All right, so the first one is, what area of the diagram is the sun located? So you did have to find the sun. It is right there. Which area is it? Main sequence. That's what I meant by area, not middle, but the actual name of the group. Now it says, name the star that has similar temperature and luminosity as the sun. So there's the sun. What's one similar to it? Alpha Centauri. Really?
Yeah.
Really? Okay, I like Centauri better. What do Polaris and the sun have in common? Or, yeah, same temperature and or color. Either answer would have been good, not luminosity or size. What's the name of the hottest star labeled on the diagram? Yep, right there. So it's the one closest to the 30,000. Which star has the same luminosity as Alpha? Alpha what? How did you say it again? Well, how'd you say it? It's the sun, yeah. Okay. And you skipped 6. So 7, name a white dwarf. There's 2 labeled ones. Protocyon B and, well, whatever that word is. And I think it's pronounced Betelgeuse. What color is it? Okay, so Betelgeuse, bring it down. We're kind of in between the orange and the red, so I would have accepted orange, red, or orange, red. You good with that? Okay, so if you notice on the board, we are done. How's it feel?
Great.
Amazing. Actually, it feels amazing to me too, because I'm getting a little nervous of whether we were actually gonna finish. So I think it's a good time to review for that class you're going to have on Thursday. So here comes the review packet. It's very large. No, it's not all homework. That's the first page of the review. Are you sad or time is over? I have more if you want more. You sure?
Shut up.
Can't whack it with mine.
No, dude, not unless it's a funny joke I told.
When has that ever happened?
Every time I tell jokes, you silly goose. This is the homework. This homework has no directions on it, but I'm sure you could have figured it out. There's a bunch of questions, and I just want you to tell me the letter of the answer. And by letter, I mean location A, B, C, or D. That's it. Your homework is this whole first page. Yes, it's a decent amount, but like you'll see that it's a lot of repeats of the same thing over and over again.